This is the second part of Precalculus Lesson 8, Using Synthetic Division to Factor Polynomials from Section 2.3 in the College Algebra textbook. We're going to look at factoring polynomials here using what we've learned about synthetic division. Starting with the factor theorem, the factor theorem tells us that if we have a polynomial p, then the real number c is a zero of p if and only if x minus c is a factor of p of x. As an example, say I asked you to find the zeros of p of x equals x squared plus x minus 12. Well, what you would probably do is factor p of x into x plus 4 times x minus 3. Then set the polynomial equal to 0. From there, we would solve for x by setting each factor equal to 0. That results in this case in x equals negative 4 or x equals 3. Okay, so we've shown that if negative 4 is a 0, then x minus a negative 4 is a factor. If x equals 3 is a 0, then x minus 3 is a factor. Okay, this verifies, for this example at least, the factor theorem. And let's look at something that we did on the last lesson. Is we took 4x squared minus 1 divided by x minus 1/2, and we got 4x plus 2 with remainder of 0. Note here that if I take this equation, multiply both sides by x minus 1/2, I get 4x squared minus 1 equals x minus 1/2 times 4x plus 2. And then let's just give this a polynomial name so that we can refer to the factor theorem here. So we have now p of x equals x minus 1/2 times 4x plus 2. I want to factor a little further to use the factor theorem. We have p of x equals x minus 1/2 times 4 times x plus 1/2, from which we can get the zeros using the factor theorem. If x minus 1/2 is a factor, then x equals 1/2 is a 0. If x minus a negative 1/2 or x plus 1/2 is a factor, then x equals negative 1/2 is a 0. Now let's look at the polynomial. P of x equals 2x cubed plus 5x squared minus 11x plus 4, which has a 0 of x equals 1/2. We want to find the rest of the real zeros and factor p of x. So we're given the 0 of x equals 1/2. That tells me that I have a factor of x minus 1/2. So we're going to think back to synthetic division, where we divide p of x by x minus c. And here in this case, c would be our 1/2. We would put the coefficients of p of x, which are 2, 5, negative 11, and 4, noting that p of x is in descending order. Bring down the 2. 1/2 times 2 is 1. 5 plus 1 is 6. 1/2 times 6 is 3. Negative 11 plus 3 is negative 8. 1/2 times negative 8 is negative 4. 4 plus negative 4 is 0. So we definitely want a 0 here to be able to proceed. And from here, I can factor p of x into x minus 1/2 times 2. Remember, we dropped the degree down 1 from p of x. 2 times x squared plus 6 times x minus 8. Okay, so I want to do two different things here. I want to factor p of x, and I want to find the real zeros. We're almost there with factoring p of x. In fact, a hint here is that when I'm using synthetic division, as soon as I get to a factor that's a quadratic, I'm going to stop using synthetic division and just use what I know about factoring. So let's go ahead and factor p of x a bit more by pulling out a 2 from the 2x squared plus 6x plus minus 8. We then have 2 times x squared plus 3x minus 4. Okay, and hopefully I can finish factoring p of x here. X minus 1/2 times 2 times x plus 4 times x minus 1. Okay, so we have p of x factored. Having p of x in factored form, I can find the zeros fairly easily. X minus 1/2 is a factor, so x equals 1/2 is a 0. 2 being a factor doesn't give me any zeros. X plus 4 being a factor gives me a 0 of x equals negative 4. And x minus 1 being a factor gives me a 0 of x equals 1. So I have my zeros. I've factored the polynomial. And let's move on. Try on your own number 2 today is that, given the 0, x equals 3/2 of the polynomial p of x equals 2x cubed plus 3x squared minus 29x plus 30, find all real zeros. Now we have a polynomial, p of x equals x to the 4th plus 4x cubed minus 2x squared minus 12x plus 9. We're told that x equals 1 is a 0 of multiplicity 2. And we want to find the rest of the real zeros and factor p of x. So let's go ahead. We're going to divide by x minus 1 here. If x equals 1 is a 0. So we have a c value of 1. We put the coefficients of p, 1, 4, negative 2, negative 12, and 9, noting that p of x is in decreasing order. Bring down the 1. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. Negative 2 plus 5 is 3. 1 times 3 is 3. Negative 12 plus 3 is negative 9. 1 times negative 9 is negative 9. And 9 plus a negative 9 is 0. Okay, so at this point we can write p of x as x minus 1 times 1 times, drop the degree of x of p of x by 1, so 1 times x cubed. Okay, just a sec here. So x cubed plus 5x squared plus 3x minus 9. Okay, so where do we go from here? Well, because x equals 1 is a 0 of multiplicity 2, I can divide by x minus 1 again, and it should work. And so this time we're dividing x cubed plus 5x squared plus 3x minus 9 by x minus 1. Well, if you look here, I already actually have what I need to do a second synthetic division here. I have 1 times x cubed plus 5 times x squared plus 3 times x minus 9. So I'll just put some space, draw a line, bring down the 1. 1 times 1 is 1. 5 plus 1 is 6. 1 times 6 is 6. 3 plus 6 is 9. 1 times 9 is 9. Negative 9 plus 9 is 0. Voila, we've got it. So now we can factor p of x further into x minus 1 times x minus 1. So now I'm factoring this part of the polynomial. This part factors into x minus 1 times 1 times x squared plus 6x plus 9. Let's go one step further and factor p of x as x minus 1 squared times x plus 3 times x plus 3. Or I like to, if we have x plus 3 times x plus 3, I want to write that as a square just to make this look a little cleaner. So let's write our final factored polynomial as p of x equals x minus 1 squared times x plus 3 squared. From here, we should be able to get all of our zeros. We can see that x equals 1 is a 0 of multiplicity 2. So x equals 1 is a 0 of multiplicity 2. And from x plus 3 as a factor here, we can see that x equals negative 3 is a 0, again, of multiplicity 2. Okay, so we have our zeros, we have our factored polynomial. Let's go on to the last try on your own for today, number 3. For the polynomial, p of x equals x cubed minus 11x squared plus 37x minus 35, whose graph is shown below, find the real zeros and factor p of x. So this graph is what you need to solve this problem. If you look carefully at the graph, and if you keep in mind that the x-intercepts correspond to zeros of a polynomial, I think you'll be able to solve this last problem here. And as always, if you have any questions, please ask.